Okay, in this video we're going to talk about kinematics in terms of graphing. So we're going to learn how to draw a position time graph, a velocity time graph, and an acceleration time graph. We're also going to learn about what those graphs mean. We're then going to talk about motion diagrams, and then we're going to go into problem solving with more difficult problems than what we've seen before. Okay, so the first thing we're going to do is we're going to talk about position time graphs. If you have a TI-83 calculator, what I want you to do is I want you to go into Stat, and I want you to go ahead and enter the T data, the time, into L1, and I want you to enter the displacement or position data in L2. So if you have a TI-83, you're going to go into Stat, and you're going to enter the data by edit, and you're going to enter T in the L1 because it's the independent variable, and the dependent variable is going to be your position. If you don't have a TI-83 graphing calculator, but you are on your computer watching the video, and you happen to have Excel, what I want you to do is pull up Excel and enter your data into A and B, as I've done here. Okay, now what we're going to do is, and for those of you that don't know how to plot data on Excel, you might want to go ahead and watch this. What I'm going to do is I'm going to do Insert, and I want to insert a scatter plot with no lines connecting the data. Okay, so I'm going to pick this one. Okay, so there's my graph. Notice how easy that was. Here's my independent variable, here's my dependent variable. Okay, so it's already already done for me. Now what I'm going to do is I'm going to go ahead and select the data points, and I'm going to go into Design. Your Excel might look a little different. I have Office 365, and it did take me a while to find this. Usually my trend line, add trend line, was over here, and now I have to go over to here to add chart element. So usually this stuff is spread out all over here, and I can see these little icons. And so you want to go to trend line, and then you want to go to more trend line options. The reason you want to do this is you want to see the equation for your line of best fit. Also, you can set your y-intercept to be whatever value you want it to be. I just want to have my equation on the graph. Okay, so I'm going to go ahead and do that. Select equation, and then that's it. So there is my line of best fit, and there is my equation. My equation for my line is y equals 5x. Okay, now when we plot data, if you look here, there's our data. We're going to draw this line on that graph, and so I'm going to go ahead and take a line, and I'm going to draw it. I'm going to make it a different color. Let's make it green so you can see it. So I'm going to start here, and I'm going to draw my line. There's my line. Now the equation was y equals 5x. Okay, so with an equation y equals 5x, we're going to have to change that around a bit. So let me show you how to do that. First off, what did we plot on the y-axis? That's right, we placed d, the displacement. What did we plot on the x-axis? T, the time. Okay, now we need the units of our slope. Well, that's just going to be the units of the rise divided by the units of the run. And that's going to be meters per second. Meters per second. Okay, I'm going to put that whole thing in parentheses so that I know that that's one quantity. Okay, so there's my equation. Also, I have an I hat here, so I might want to go ahead and add that. And now I'm going to put the caret over top of this, and I'm going to put a vector sign there. So this is actually what I end up with for my equation for my line of best fit for this data. Okay, so that's my equation. Okay, so what is the slope of, so what you're going to do is you're going to write this equation down where it says equation. Okay, so you're going to write that down where it says equation. Now, what is the slope equal to? Okay, the slope is going to be equal to 5 meters per second I hat. Okay, so we can see that the slope is what? What are the units of meters per second? Let's go ahead and erase this. That's right, it's a velocity. So you can see that the slope of this line is going to be the velocity of the motion. Okay, if you have any questions, go ahead and make a note in your lecture notes and you can ask me in class. Okay, so now what we're going to do is we're going to plot a velocity time graph. So here again we look for our independent and dependent variables. Notice that the time is the independent variable and the velocity is the dependent variable. That means that time is going to be L1 and velocity is going to be L2. When you put them in your calculator, you should come up with a line of best fit. And in this case, I've already drawn the line. It is a linear relationship. Let me get rid of that. Okay, so we're plotting velocity in meters per second I hat with respect to time. And so what I'm going to do is I'm going to go ahead, while you do that, I'm going to go ahead and plot the data in an Excel spreadsheet so I can see the line of best fit. Okay, remember to do your trend lines. So you're going to add a trend line to the data. And again, if you click on more trend line options, then you can go ahead and add in a line of best fit. And so what you should end up with for your equation for your line of best fit, I'm going to go ahead and type it in, is y is equal to 20x. Okay, now I also ended up with like 20.1. I'm not sure about that, but I'm going to go ahead and put that 20.1x. Okay, now we're going to replace our y with what we plotted on the vertical axis. And what did we plot? We plotted v. And what did we plot on the x-axis? T for time. So now we take the units of our slope, which are going to be the units of the rise divided by the units of the run. And that's going to be meters per second divided by seconds. Okay, so there's our equation for our line of best fit. I'm also going to put the direction because it's I hat. Here we have our vector sign and here we have our unit vector. Okay, so what is the slope? It's 20.1 meters per second per second. And what does that end up giving us? This right here. That ends up giving us the velocity, or I mean the acceleration, doesn't it? Okay, look, meters per second is the units of meters per second squared, which is the units for the acceleration. Now what we're going to do is find the area under the curve for 3 seconds. Now, you'll notice that it's a triangle, right? So we're going to have to go ahead and find the area under the curve. Well, that's just going to be 60 times 30, which ends up giving us, let's see, 180. And then we're going to divide that by 2. So that ends up giving us what? That ends up giving us 60. Sorry, I meant it's 60 times 30, so let's write this out. 60 times 3, sorry, 60 meters per second times 3 seconds. Now that gives us the area of the rectangle. We want the area of the triangle. So we're going to go ahead and cut that in half. So we're going to take that whole number and divide by 2. And so that's going to give us what? That ends up giving us 90 meters. Okay, so that's the magnitude. Okay, so when we look at the area under the curve, sorry, that goes there. So when we look at the area under the curve, we're looking at 90 meters. And meters have the unit, are the unit for what? That's right, displacement or position. Okay, and again, because this is a positive number, we're going to put I hat, and we're going to put I hat there. Okay, so what does this tell us? It tells us that when we have a velocity time graph, the slope of the line is the acceleration, and it tells us that the area under the curve is the position or the displacement of the object. So for those of you taking calculus, what does this mean? Well, what it means is if you take the derivative of a function, a velocity function, with respect to time, you're going to get the acceleration. Okay? If you take the integral of the velocity time function, then you're going to get the displacement. Okay? So when you take a derivative, you're finding the slope of the line. When you take the integral, you're finding the area under the curve. Okay, so here we go. We're plotting 20 meters per second squared on our acceleration time graph. And again, I'm just plotting the data. So if you get 20.1 or 20, it doesn't matter. So if you have 20 meters per second as your acceleration, it's going to be that value for all time intervals. And why is that? Because at 1 second it's 20, at 5 seconds it's 20. So it's going to be a horizontal line. Now, if we want the area under the curve at 3 seconds, we just take the 20 times the 3, which gives us 60 meters per second squared times seconds, which gives us meters per second I hat. And what is that? That's the object's velocity. So if I have an acceleration time graph and I find the area under the curve, I get the velocity. So let's summarize this. I always call this the Diva rule. So you take D, V, A, Diva, okay? If you go this way with Diva, oh, I need an arrow on that. So let's do this. If you have Diva and you go this way, you're finding the slope, okay? So this is basically the slope. So if I take the slope of the position time graph, I get the velocity. If I take the slope of the velocity time graph, I get the acceleration. Now, if I go in the opposite direction, it's the area under the curve. So I'm just typing area. How are you going to remember this? This is how I remember it. It's either the slope or the area. If I'm starting with D, I'm looking for the slope. If I start with A, I'm looking for area. Okay, so if I start with A, and I go this way, I'm looking for area. Okay, so Diva is the slope, A is for area. Okay, now if I take the area under the acceleration time graph, I get velocity. If I find the area under the velocity time graph, I get position. Okay, this is a really neat rule, or a little neat thing for you to remember, because this comes up all the time when you are analyzing graphs. And I have seen this come up on the past 2 times that they have given AP exams. So this is definitely something that you want to remember. Okay, in class you're going to do this one. And basically what you have is a position time graph, and there's your position time graph. Yours may look a little different than mine number-wise. But basically, I want you, when you come into class, to be able to tell me what this motion is and to reproduce it. Okay? So you're going to get in groups and you're going to reproduce this motion in class for me. Okay, in the next video, I'm going to go ahead and cover motion diagram.